for the Spring user group? Okay, good, good, good. And who signed up via the Java user group Berlin? Ooh. I don't have, okay. Last one, microservices user group. A few people, cool. Who signed up on all of them? Good, you didn't take away seats. Who signed up on 2 groups? A few. So I hope you eat double at least if you take 2 seats. So as you may have seen last minute, we updated the event a bit because we have good news. So it's not just Berlin who does the event, but also our friends in the other side of the world, in San Francisco. There's a small startup that decided to host the event as a breakfast event today. So they have croissants. And the founder of the company will present a very short insight into the tool, into IntelliJ plugin that he is currently creating called Sweep AI. Who's using that? Good. So you will learn about it. Who knows Visual Studio Code? Good. And Copilot? Who likes Copilot? Who wants to have it for IntelliJ? Yeah, good. So that's what you will hear from him. So I'm glad that William will give you a glimpse into what he's been working on for a few years with a small team that just got the next funding round. So you can send the wishes that you want to have in the tool in our chat. Cool, huh? So you saw that maybe it's somewhere here. Okay, some papers are there, hand them over. There's a QR code and there's a link. It's called link 3, right? linktr.ee/x2c. Why C? I don't know. BER. Yeah, very cryptomatic. But with that, you get to a link aggregator page with a few links, right? So one link, and it's the YouTube link, okay? You go to a YouTube live stream from JetBrains. And with that, you can join from everywhere in the world. And there's user groups that ask me for that link, namely the user group JAG in Tehran, in Iran, and the one in Emirates. So, and we will distribute the link also to other channels. So we will have online viewers as well. They will also ask questions, right? So you can do that then in the WhatsApp group to the speakers. You can discuss things, or you can go to YouTube, and there's also a comment section that is handled by JetBrains nicely. So that's the options. There are small things in there that you will find later on. I talk about it. And for now, I would say I give the word to JetBrains briefly before we hit off the first session by Chris Richardson, 60 minutes on microservices. Afterwards, 20 minutes by Vaughn Vernon on similar topics. And then we have maybe a very short break, maybe 1-2 minutes, bathroom break, right? Restroom break. And there we continue with a sneak peek that I prepared with a remote speaker, and then another remote speaker, which is then from San Francisco joining. Then we have another break where we move into a panel discussion, right? And there we'll introduce the panelists individually to you. And I hope you will learn something today, something new. Microservices are around for a long, long time, so it's very tough probably to come up with new things, I mentioned, but I trust Chris as he built and run also the East Bay JAG and microservices.io. Who has been on microservices.io already? Good. That's nice. So I now finally you have time to see the person and get all the questions answered you couldn't find there. So, Theodore, thank you so much for having us. We are pleased and yeah.
Yes. Thank you so much. I'm so happy to host you and to help our wonderful speakers, to help Benjamin, to help Chris, to have Vaughn. Let's give them a quick applause to today's speakers. So I work at JetBrains, and I'm actually product manager for Kotlin support, and I'm a bit interested about how many of you actually use Kotlin. Can you raise your hand? Okay, wow, wonderful. And how many of you actually use it in production for server side? Wow, wow, also many. So yeah, please enjoy you today. And also, if you use Kotlin for server-side for production on multi-platform, please come and catch me after the event. I'll be happy to speak with you. And basically, we're actually currently doing a series of case studies with different companies who use Kotlin for server-side, and that can actually maybe help you boost your employer as basically as a good employer for developers. And for us, it's also super interesting how exactly do you use Kotlin for server side. And also I wanted to promote a bit our new tool called Kotlin Notebooks. And basically, have you heard about Python notebooks, Jupyter notebooks? Like, raise your hand, please. Yeah, so now you have the same, but in JVM, right? Wonderful. And it was a paid feature. Now it's like unpaid. It's already in IntelliJ IDEA. So basically you can have all the notebooks you wanted to do in Python, but now in Kotlin, and you actually can use your Java classes there. You can use it for prototyping, you can use it for documentation, or like, for example, for comparing libraries, benchmarking them, or creating presentations. So check it out. Yeah, so some people actually asked me about today, so that's why I'm saying. So yeah, I'm extremely happy to see you all today. Please enjoy. Let's welcome Chris. Please, Chris, the one and only.
Thank you. Can you hear me okay? Oh, that's good. Anyway, it's an interesting comment Benjamin made about like, well, what could possibly be new in microservices? And you know, to a certain extent, not a huge amount, because I feel like a lot of the mistakes that people make with microservices is actually just neglecting the fundamentals, some of which are like 60 years old. So if nothing else, this is a presentation just reminding people to actually, you know, apply fundamental software design principles. And the motivation for this talk was, I think it was 2 years ago. It was like one Thursday, I had a conversation with a friend who was modernizing a legacy application, maybe even a mainframe based. And it was like, our application is beep, beep, beep. It's so complex and difficult to change. And it's like, yeah, that's just ancient legacy code, right? But then the next day, I had a conversation with a friend who was working on a 2-year-old microservices application, and they said exactly the same thing. You know, so it's kind of like today there's this phenomenon of like instant legacy, unmaintainable code, and we're just creating it faster. And I suspect that with Gen AI, it's going to be even, you know, accelerate the creation of piles of beep, beep, beep very quickly, right? So, and I just saw that, you know, that problem occurring a lot at organizations that I've worked with. People are just creating a mess of their microservice architecture. And so the motivation for this talk is just to present a set of 11 rules, none of which are really earth-shattering. I mean, one of them is just think things through. But hopefully that will prevent organizations from making a mess of their microservice architecture. So a little bit about me, you know, I've been building software for, wow, it's just a million years now. It's kind of funny to think that like my first paid job, programming job, was back in the summer of 1982. before I went off to college. So I'm a little old and my knees hurt. And originally I worked in Lisp. I built Lisp systems. So everything from like runtimes with garbage collection compilers all the way up the stack to IDEs. And then eventually Java created the original Cloud Foundry back in the early days of cloud computing. And then for quite a while now, I've just been pretty much focused on the microservice architecture, created microservices.io. And I just help organizations around the world improve their software architecture, primarily by helping them use microservices correctly, or just telling them not to use microservices, stick with the monolithic application. And my book, Microservices Patterns, that actually came out 7 years ago now. And it's actually still very current, but I'm in the middle of writing the second edition, which will be out, I can't even claim real soon. It's at least a year or two away, I think. Anyway, enough about me. Let's talk about the rules. Can you actually see my slides, by the way? Yeah. Oh, that's really funny. I can see them. So I guess there's some kind of technical glitch. So just imagine a slide with a bunch of boxes. And on the left, there's a box with software development rules. On the right, there's a box with architecture rules. And then at the bottom, there's some foundational rules. So there's actually 3 categories of rules around the mic that I'm going to talk about today. So I'm going to talk about software development rules. And the good thing is you can just imagine what I'm going to talk about visually. So at the heart of software development is really like this feedback loop. So IT obviously takes requirements, does development, they implement features, fix bugs, mitigate risks, eliminate tech debt, and then they push those changes into production and put it into the hands of the users. And then conversely, there's a feedback loop. Hit the pause button here. If nothing else, this is a lesson on the importance of simplicity, right? Where, back in the old days, you just plug the laptop into a projector and stuff would work. Whereas now it's like some fancy schmancy kind of streaming thing, and it's really hard to get working. And a lot of software is like that. I was like reading about the Amazon outage, right? And just to provision an EC2 instance, which you think would be really simple, there's just layers and layers of software that Amazon have implemented so they can provision EC2 instances at scale. Like it's actually relying on a NoSQL database, DynamoDB. And then there's all this complex algorithms. And it just sort of makes you wonder, do you need things that complex?
Yeah, maybe not. Yeah.
I'm trying to pass the time here.
Yeah. Where should they be presented? So, yeah, I talked to the streamer, but I don't know, like what's going on.
Okay.
She should grab the screen, right?
Yeah. So let me just keep talking while he figures stuff out. So at the heart of software development, you've got this sort of feedback loop. Developers develop, push changes into production, and then feedback comes from both production, which is sort of like validating technical decisions, but also from users. And that enables the development team to learn, to make course corrections, and so on. But the problem you have with a lot of software delivery, the cycle time is really long. Like organizations, maybe they deploy once a month, right? Which means that you only have 12 times a year to actually learn and make course corrections. In other organizations, it could actually be a lot slower. And then if you're doing some big bang rewrite, maybe the cycle time is measured in years, right? So you commit to a certain course of action, and then 2 years later, you realize that on day one, you made a fatal error in your design, right? So these long loops are actually quite bad. And it's particularly problematic in today's world, which is actually, if you haven't noticed, rather unpredictable, turbulent. The technical phrase is volatile, uncertain, complex, and ambiguous. And then if we're building complex applications using brand new technology, if you have a slow feedback loop, which means you're learning very infrequently, there's a pretty good chance that you are building the wrong application, the wrong way. You're not meeting the needs of the users, and then you're making all of these unvalidated technical decisions, and it's likely to be a mess. So it's extremely risky. So what you need for modern software, to deliver software in the modern world, right? In particular, in order for businesses to thrive in the modern world, the software systems that power those businesses need to be developed using what is known as fast flow, which is where you're continually delivering software changes into production and into the hands of the users, and then conversely, continually learning. So instead of, once a week, you're actually deploying into production, perhaps as often as once per developer per day, which is giving you opportunities to rapidly course correct. Let's just kind of catch up with my slides here. And just out of interest, in terms of like how often your organization is deploying into production, is anyone doing it like more than once a day?
No.
What about like, I don't know, what's the other, once a week? Once a month? Less often than once a month? Yeah, so it's sort of a mixture, right? And there's a lot of evidence to show that, this comes from the book Accelerate, which is really the science behind DevOps, that organizations that have mastered fast flow are actually more successful. And then not only that, the developers tend to be happier as well. It's not so much of a death march. So how's it going?
Shit.
Oh, there was a not safe for work response just then. I kind of wanted to see my slides so I could keep going.
Yeah. Do you have a slapstick joke, like a elevator joke? Nothing?
No.
What's the best food in Seoul? Okay, finally you have the link.
Okay.
That's when it changed the presenter laptop last minute. Then of course, laptop is not connected to the stage. Okay. Finally. Switch
Well,
production last minute.
well, you actually, it's okay to continually push changes, but you need to have a really good test suite, right? And validation. And then in production, you need to have really good monitoring so that if there is a problem, you can
do everything now.
you can very quickly roll back. Do you need to mute that?
You think so? And now? Yeah. Cool presentation. I have no idea. This should have been tested. I put everything together from the whole event, but nothing like this here. It was like a task of somebody else.
So anyway, you need to have clear ownership, good test suites, monitoring, and then the ability to roll back really quickly. And I guess I should also say, I mean, you need to have some degree of fault tolerance so you can instantly fail over from a non-functional solution to one that works.
That doesn't help here, you know. Screen share, Bildschirmfreigabe erlauben. That sounds good. It's also German. I never use German computers. Some Bildschirm teilen. Oh, maybe that's better, I think. Do you see? Yeah, maybe. Yes.
Okay.
Now we can go full screen. Can we?
Yeah, hit
No, I wait for my presenter to answer me for the streamer. Okay, it looks good. Then we go into full big, or like this. No?
Yay.
Where were you? Here? I have no idea.
Okay, let me just quickly show you the amazing slides that you missed. Right. Go. You know, this was a really cool picture of the moon that I took. Okay, and then we got to the feedback loop, and you know, if you don't have fast feedback, you risk building the wrong application, not meeting users' needs, and they're actually potentially building it the wrong way because you're not validating your design decisions promptly, and bad design decisions just stack up. So you need fast flow, right, in order for businesses to thrive in today's world. And to do that, you need what I call the success triangle, which is a combination of three things. It's the right process, which is actually DevOps as defined by the DevOps handbook, which is actually a set of principles and practices for delivering software rapidly, frequently, and reliably. It's not a job title. You need to have the right organization structure, which today is defined by team topologies, which is a set of organizational patterns for fast flow. And you need a fast flow architecture, which if you're building a sort of relatively small application and it's a relatively, with only just a few teams, then perhaps the monolith is the right choice. Whereas if you're building a large complex application with large numbers of teams, quite possibly the microservice architecture is a better choice. And this, by the way, is kind of a really important concept that if you are using microservices, you need both the process and the organization to match. You need all three. And if you don't, that in itself is actually one key, is a critical anti-pattern for microservices adoption. So yeah, as I mentioned, DevOps set of principles and practices for fast flow, delivering software rapidly, frequently, and reliably. And that actually leads to rule number one, which really, rule number one should be just do DevOps as defined by the DevOps handbook. But that's kind of that's a big complex set of things to put in place. So I've just defined rule number one as practice continuous delivery, or specifically practice continuous deployment. And that's actually a practice that predates DevOps by a number of years and then got incorporated into it. And just the general notion is that, Git is the source of truth. Developers commit frequently, at least once per day, to trunk. And then that actually triggers a highly automated deployment pipeline. Which then leads to rule number two is have a fast deployment pipeline, right? So as I mentioned, developers are committing changes, ideally at least once per day. So it's a stream of tiny commits. Each one of those should trigger the deployment pipeline, which compiles, tests, packages, and then deploys the application into production. without any, without any reviews, right, or any manual testing. Everything to verify that something is production ready should be baked into the deployment pipeline. And it should execute really quickly. 15, 20 minutes, any longer than that, and then you end up context switching and going off and working on something else, which actually reduces your productivity. So it has to be fast. So just out of interest, is anyone actually, well, practicing continuous deployment like trunk-based development here? Yeah, it's scary, right? And what about having a fully automated deployment pipeline? Yeah, I mean, that's also scary, right? It's much better to go ask a VP for approval about your Git commit before deploying it. I mean, I'm sort of joking. I mean, there are actually sort of technical challenges to doing this right. But I think, so it is technically, it can be quite hard to put in place, but then there are just sort of organizational, cultural sort of bad practices that really make putting this stuff in place. So anyway, so that's rule number 1 and rule number 2 to do with process. Then you have rule number 3, which is structure your organization according to team topologies. And there's a bunch of key concepts with team topologies. So the first is the idea of team type. So team topologies define several different types of teams. Most of the work is done by what are known as stream-aligned teams, which is basically a fancy way of saying that a team is responsible for the end-to-end flow of work. In other words, taking in requirements and then turning them into code running in production. This slide gets better. I would hold off taking a picture. The teams are small, like 5 to 9 people. And that's really important because if you work with the same group of, small number of people for a long time, well, hopefully you don't hate them, right? But in a healthy way, that should lead to a high level of trust. Versus being on a massive team where you don't know people and you're afraid to make a mistake and so on. So anyway, so the work is done by these stream-aligned teams that work pretty much independently, right? And they're clearly cross-functional. They're not handing off code to a test or a QA organization. But then they're supported by 3 other types of teams. There's what's known as an enabling team, which actually acts as a consultant and helps teams acquire new skills. You have these complicated subsystem teams, which focus on something that requires deep technical knowledge like math, right? So maybe it's some machine learning thing. And then the last part, which is really important, is you have these they used to be called platform teams, but now they're called platform groupings in the new version, 2nd edition. So I shortened that to platform groups. And they create platforms, and platforms are an artifact that reduces the cognitive load, the workload of stream-aligned teams. So like a self-service deployment platform, for example, would be an example. So those are the team types. And then there are interaction types. So the 3 ways within which teams can interact. They mostly work independently, and one team consumes the output of another team as a service. Hence this X as a service interaction. So it's not like you're regularly handing off work. These teams are working independently the majority of the time. But then sometimes teams need to collaborate to discover valuable new things. So maybe there's a platform team that have a platform, and they actually work with a stream-aligned team to enhance the platform. And then obviously enabling teams, they're consulting teams. They facilitate the adoption of new skills by the stream-aligned teams. So that's the big picture. You've got these small teams working independently, and collaborating when they need to, for the most part. So they are not regularly having to hand off work. And it's a really important attribute of high performance teams. And then there's a really important principle, and there's this idea of cognitive capacity. So the human brain is only capable of so much mental effort, right? And a team sort of collectively has a certain cognitive capacity. And then the software that they own imposes a cognitive load. In fact, the environment within which they're working imposes a cognitive load as well. And you do not want that cognitive load to be greater than the cognitive capacity of the team, because if they are overloaded, then they basically, well, that's sort of, they're mentally overwhelmed. That just leads to stress and burnout. So you kind of have to respect the cognitive capacity of the team. As I mentioned, you have these platform groups. And so one way of reducing the cognitive load, so rather than the team having to figure out how to do deployments, you provide them with a deployment platform, which is maintained by the platform group. And the stream-aligned teams, like, well, obviously in an ideal world, they do a git push, and that kind of magically results in their service being deployed as part of the deployment platform. And once again, it's just consumed as a service. You don't have meetings to do deployments. You just do a git push. And in another talk, I gave one last week, I talked about 6 different platforms that can support the stream-aligned teams who are developing services. Actually, that looks like an older link, but if you go to microservices.io, I posted the new presentation just yesterday. Okay, so yeah, we've got, practice continuous deployment, fast deployment pipeline, apply team topologies. Well, the 4th rule is provide a great developer experience. Which sounds kind of fuzzy, right? Like, after all, for as long as we've had developers, there has been this concept of a developer experience. But what's new is there was a paper, I guess 3 years ago, that described how developer experience consisted of 3 key things. Cognitive load, which I've already talked about. Flow, which is opportunities to be able to focus and do meaningful work without constantly being interrupted by meetings, Slack, everything else that goes on in modern environments, right? Which is like, I don't know how people get work done, in the office. And then also the importance of feedback. So to have a great developer experience, you have to minimize the cognitive load, reduce the amount of mental effort it takes to get your job done. You have to provide lots of opportunities for flow so people can focus on their work. And you have to provide fast feedback from colleagues, like reviewing your pull requests, which is why pair programming or mob programming is a good thing. The tools should be fast. The deployment pipeline should be fast, as I mentioned previously. And you should get great feedback from production. So you can easily learn from your users. And collectively, that provides a great developer experience. And this book just came out last week called Frictionless, which is like such a perfect name. And it's really, the idea of great developer experience isn't about making developers happy, although it does. It's actually about removing the friction that slows down your business. So I encourage everyone to go read this book. I think it's really good, although it does seem to have a habit of mentioning AI on every page, which is kind of funny. Okay, so those are software development rules, right? And as I said, none of that is like earth-shattering, right? It's pretty foundational kind of concepts. But, for a whole bunch of reasons, a lot of companies struggle to put them in place. One of the interesting things, by the way, the book talks about making developer experience a competitive advantage. And my first thought is, why would it be a competitive advantage? You just read the book and do it, right? It's written down on how to have a great developer experience. But then I thought about it some more, and the problem, many organizations have a problem changing and adopting new things, which is why, even though there's a book on how to have a great developer experience, most organizations are going to struggle to implement it because of internal culture and politics and legacy architectures and so on. And hence it can be a competitive advantage. And I think, same reasons apply to following microservices rules as well. If you follow them, you will have a competitive advantage, but there are barriers to actually adopting them. Okay, so I want to just talk about what rule number 5, which is use a deliberative design process, which is actually a fancy way of saying think things through. And part of this was inspired by a paper I read that said that, architecture is a set of design decisions. And what that means is, in order to solve a problem with like your current architecture, an architect actually ended up figuring out a solution after like brainstorming some candidate solutions and then picking a favorite solution. And that favorite solution and a good solution is actually an architecture modification. Adds, deletes, updates architectural elements and the relations between them. And that modifies the architecture. And now you have an updated architecture. And essentially, the architecture that you have today is really the composition of all of the past design decisions that you've made. Kind of like how event sourcing works, where you're applying deltas to compute the current state. So, it's all about making decisions, or software design architecture is all about making decisions, kind of like whether you explicitly make them, and whether or not you think things through, or whether you just go, well, I'll just copy what that person on Twitter said, right? Or, Twitter-driven architecture and so on. So I kind of like distinguish between irrational decision-making, right? Which I think actually happens more than we will admit. And sometimes actually there was a talk at QCon last week about hidden decisions where you've just you've made assumptions and sort of implicitly made a decision without really thinking about it. So that's another category. But what I recommend which is rule number 5, is basically think things through, sort of understand your context, define the problem properly, which is not always actually easy. Figure out evaluation criteria so you can help judge the suitability of a solution. Brainstorm some candidate solutions, evaluate the trade-offs, pick the best one, document it, and just sort of continue around this process, right? And this is one of the reasons you can't just take things off Twitter or just do what you did before, is because your context changes. And what worked for someone or what worked in the past for you might not work today in your current application. So you really have to think things through. And one of the kind of like, in the context of the microservice architecture, it's sort of like, one critical decision is, well, we have a monolith, should we start adding new services, or we have existing services, should we add a new one? And I think it's really common to just adopt the microservice architecture because you just think it's the modern thing to do. Or if you have a microservice architecture, keep adding new services just because, well, hey, it's microservices, right? Which means they should be small and numerous. But in reality, if you have to think things through and only add a new service if and only the benefits outweigh the drawbacks. And then it's kind of like, well, what are the evaluation criteria for deciding whether you should add a new service, which is actually a whole other topic. But I have what I call dark energy, dark matter, which are basically 10 dark energy forces, which are reasons to actually have services, and then 5 dark matter forces, which are reasons to not have services. And for any given scenario, you have to make the appropriate trade-offs. So I encourage you to go read up on that. So it's sort of like, don't use microservices unless you actually think it is worthwhile, right? There's a genuine need for them. And don't add a new service unless it actually solves a tangible problem. Because otherwise you'll just create an overly complex, fine-grained architecture. And I've quite often seen this sort of anti-pattern, which is like one service per developer. So you have a team, and they sort of have, a team of 10 people. They all have 10 services. I mean, there are even worse examples than that, right? But sort of a rough rule of thumb is, yeah, a team should at most have one service. Because it solves the problem of team autonomy. So, coarse-grained microservice architectures, or stick with the monolith. Okay, but if you do go down the route of microservices, then you need to follow these architecture rules, which actually define the characteristics of your services. And the first 2 rules are actually kind of defining characteristics of the microservice architecture, which actually are quite often ignored, and which can lead organizations to be in a world of pain. So what is the microservice architecture? So my definition, it's basically, whereas the monolith consists of a single component, a single deployable unit, like an executable jar file, a microservice architecture is simply an architecture that has 2 or more components, or more specifically, we'll say executable jar files. One handling orders, the other one handling fulfillments, right? That is a microservice architecture. But then there are 2 defining characteristics that are absolutely essential. And they're actually where the majority of the benefits from using microservices derive. Number 1, services should be independently deployable. Number 2, they should be loosely design time coupled. And sort of independent deployability essentially means each service has its own deployment pipeline. But I'll talk more about that in a minute. But yeah, critical thing is having a loosely design time coupled architecture, which means that services should rarely need to change in lockstep. So when the customer's team makes a change to the customer service, the vast majority of those changes should not result in the order team having to make changes to their service. And actually vice versa for that matter. So that means that services should have stable APIs. And the reason for that is really simple. Teams should be working independently, which requires, by definition, the things that they work on to be loosely design time coupled. And it's very much an anti-pattern where services are actually constantly changing together, right? That is a huge red flag that indicates that your service boundaries are not actually defined correctly. I think it's quite common. And if you do have tightly coupled services, then you end up being in a world of pain. It's basically a version of the distributed monolith anti-pattern, because you have to to make a change to a service API in a modern zero downtime environment where changes are like you have rolling updates. It actually is quite complicated and involved to evolve a services API, and the teams have to coordinate, which kind of defeats the purpose of having microservices in the first place. So if you actually have two subdomains, two slices of functionality which are owned by different teams and they are tightly coupled, they should be packaged together. And this is sort of kind of a form of cohesion. Kind of coupling and cohesion, the two ancient design principles. It also means that your services should look like icebergs. The visible part, the API, should be small and stable and hide a much larger, more complex, unstable implementation. So the team can change their implementation and rarely need to make breaking changes to the API. I mean, strictly speaking, they can make additive backwards compatible changes, and that would be okay. But you should rarely make breaking changes. So I guess that was rule number 6. Rule number 7 is actually have independently deployable services, which means that a service can be tested and then deployed in isolation from any other service. So if the service calls some other services in its deployment pipeline, they are actually mocked. They're replaced with test doubles so that the service can be tested in isolation. And you have to design your services so that they have this property. And a quite common anti-pattern is for an organization to build an application comprised of microservices, and then they release at the application level, right? And so they, once again, this is a form of the distributed monolith. They're actually, they've got the complexity of the microservice architecture, but then they're treating it as a monolith and just doing these giant periodic releases with complex end-to-end testing, which actually takes forever. It's kind of complicated. It's kind of brittle. It's quite common for end-to-end tests in a microservice architecture to just fail randomly. So you end up with a flaky test suite which then requires manual investigation to determine whether it's just a random bug or a genuine bug. And interestingly, the example of this messy kind of modern legacy architecture made up of microservices actually relied on end-to-end testing, and they had flaky test suites, and it was just sort of a nightmare. But people just want to do these full system releases, and it's you got to give up on that idea and just think, each service is this isolated thing. But it's like, oh, how can we do that? Well, we have to test everything together. But on the other hand, you think about, I don't know, API vendors like Stripe. They release stuff many times a day, I suspect, without having to test with every one of their customers' applications, right? If you think about it. And the reason they can do that is they have stable APIs that are managed, right? I thought it would be a great science fiction story where, like, this Enterprise, from Star Trek comes across a world where they release their entirety of their world's software on release day that happens once every 1,000 years or something. My idea, don't copy it. Okay. So anyway, those are two key, absolutely essential characteristics that people just ignore, and they end up building a distributed monolith. Then there are some other rules, like build services that are actually testable. So you can test them with automated tests. Those tests run fast. Those tests are reliable. You can shock and horror, you can run them on your laptop, right? And no, I'm not meaning the top of the line MacBook with 128 gig of memory. You should be able to run them on a reasonable piece of hardware. And as I said, services should be testable in isolation using test doubles for any of the other dependencies. So testability is really important. And then observability is absolutely essential. So if you go to microservices.io, there are 6 observability patterns that services must implement. And each one of them is a combination of code in the service itself, like instrumentation logic that that writes logs or exports metrics, and then infrastructure that collects, say, those metrics, like Prometheus, or logging infrastructure and so on. So those patterns are a mixture of code plus infrastructure. And you need that for a couple of reasons. One, it actually is part of the feedback loop that you get with fast flow. The stream of telemetry that comes out of your services gives you the feedback about their behavior and also about the behavior of the users. And then at a very technical level, this is how you verify that a deployment, an update of a service in production is actually succeeding or not, right? You do a canary deployment, you monitor some key metrics, and if those metrics go out of bounds, you actually terminate the deployment and roll back. And it all relies on you having observable services. Oh, I said that already. Okay. So observability is really important. And I just want to finish up by talking about rules 10 and 11. So rule number 10 is, instead of making, big changes that are risky, break what would otherwise be a large change into a series of smaller, safer, and ideally reversible changes. And a good example of that is the Strangler Fig application, which is a refactoring strategy where you modernize an architecture, say migrate from a monolith to microservices, by incrementally migrating functionality from the old application into a new Strangler application, which would be comprised of microservices, and you're doing it one step at a time. And the value of that is you're making baby steps, and you're constantly getting validation that you are going down the right path. You contrast that with a big bang rewrite, where you work for a couple of years rebuilding an application. It probably takes longer than you planned, and you have nothing until you're done. You haven't even put anything into production, so you've not actually validated any of the design decisions, right? And then when you put it in production, you find out that all of your inter-service communication design is messed up, right? And you then have to spend months kind of reworking those decisions. Actually happened to a company I know, where they did this sort of big bang strategy. So, so this incremental migration, small baby steps, which is actually, to be honest, is quite hard, but it actually means that you get immediate value, and you are constantly getting validation as well, that you're going down the right path, and you can course correct at any moment. And I think modern software is just full of examples of making smaller, safer, reversible changes. So like continuous deployment, where you're deploying many small changes a day. Canary deployments, where you're updating production by incrementally shifting traffic from the old version to the new version. And then if you detect a problem, you just instantly revert back. Or perhaps, if you've got some new implementation of, say, I don't know, say your billing system, right? you have a couple of ways of migrating users to that. You decide, oh, midnight on Saturday, we're going to migrate all of our users. And, it's incredibly stressful. You have an incredibly stressful Saturday night getting it to work, or maybe it doesn't, versus somehow arranging to incrementally migrate users one at a time during business hours from the old system to the new system, right? And then also another example is kind of figuring out what your true requirements are by continually experimenting, running experiments in production with new features or prototypes of new features to get real feedback as often as you can. Because there's this great study that shows that only 1/3 of your requirements actually make your product better. The other third actually have no impact on your product, and 1/3 of them make your product worse, right? So, in today's turbulent world, you have no idea what your users need. And so the only way to succeed is through continual experimentation and sort of incremental evolution of your product. Okay, so that's rule number 10. And then rule number 11 is just measure things. And there's several different types of measurement. And one of them is the DORA metrics, right? Which actually measure how fast you're going and how frequently you're making changes, and then and then the second two metrics are how reliably you're making changes. So you've got deployment frequency is how often are you pushing to production, which ideally should be once per developer per day at least. And ideally, it's just every developer is committing at least once per day, and every commit is deployed in isolation to production. Which means that, by the way, is if you have a production issue, you just look at what the most recent commit was, which is much better than looking at the past month's set of commits and figuring out which one of those has introduced the problem, right? Sort of the needle in the haystack time. You should also measure lead time, which is the time from commit to deploy. So it's measuring, kind of the feedback cycle. And then the last two things is basically how often are you breaking production, which obviously should be really low. And if you do break production, how quickly can you restore, which also should be very low. And sort of modern organizations are actually moving fast, right? Deploying many times a day. I think the classic example is Amazon, who, at one point, they were deploying every 0.6 seconds into production, right? This was Amazon.com. And they're not breaking things either. It turns out that if you make kind of practice fast flow, you end up doing it your reliability goes up. So the traditional approach is infrequent releases is actually a very unreliable way of deploying software. You should assess your developer experience. Ask the developers how they feel about feedback loops, cognitive load, opportunities for flow. So that's a question of doing surveys, mostly, but then you can get metrics, right? Like you measure your deployment pipeline, execution time, and so on. But actually just surveying developers. Can you focus? Is it easy to get your job done? Do you get fast feedback, right? Basic questions like that. And then acting upon it can improve the developer experience. And then you also should try and track architecture metrics. In particular, you want to make sure that your architecture is loosely design time coupled. And this actually has nothing to do with microservices. Pretty much every element of your software, whether it's classes, packages, modules, services, should actually be loosely design time coupled, right? I mean, this is a fundamental property of software that was discovered back in the early 70s, right? And then I think it's one of the problems most enterprises suffer from. They have tightly coupled architectures, and they need to have big projects with lots of meetings to make change because touch is everywhere. So you want to try and measure the degree of design time coupling. And one very practical way about it, in a microservice architecture, is look at services that are regularly changing because of the same underlying reason. So imagine there's a feature in Jira, right? And the Git commits point back to the Jira issue. You can analyze all of the commit histories for all of your services and look for these lockstep changes. Or monitor how often do services have breaking API changes. It's all indicative of some kind of tight design time coupling. And you should then figure out how to refactor your architecture to make things loosely design time coupled again. And it's arguable that really a lot of these metrics should actually become organizational sort of KPIs, right? Executives should be held accountable for the high software delivery performance, because it does tie back to business success. Anyway, so those are the rules. I think this is the end of my talk. Yeah, so we got those rules, fairly fundamental, nothing too earth-shattering. So thank you for listening, and I hope that you found this useful. And are there any questions?
Yes, we do have a microphone to hand over for questions. So is there any? Who's doing microservices already?
Change the slides already.
You
Sure.
already said that. So you might have some questions? No? Yes, you have one. Great.
Yes, one question. You mentioned we should be able to evolve our services independently, but I think it's because of
Yeah.
but what I discovered mostly, the greatest hurdle for this are data. Mostly if you have to introduce a new data type on your attribute, maybe for legal reasons. Yes, when you have to do it in order, you cannot implement it independently in different services. How to handle such things? Mostly if you have to distribute the data, maybe for legal reasons, for the whole organization to pass it from one domain to another one.
Yeah. Well, I mean, I would say, like, as a rule, you should try and define your service boundaries so that changes don't regularly span, multiple services, right? Because life is pretty simple, straightforward at that point. But you're right. I mean, sometimes it's unavoidable, but I feel like it should be the exception. And yeah, then you have to carefully roll out the changes, and it's slow and painful.
Okay, any other questions from the audience? Are you smiling? No? Ah, there's one from Pasha. Are you coming right up? Okay, I'm coming to you.
Oh, you met me in the middle. Thank you.
No, microservices are not dead. I sat down to him at lunch, and the first thing he asked is, "Are microservices dying?"
I mean, no one here does microservices as we see. Like 3 people.
Yeah.
Who is going to do microservices in the next 2 years? I mean, probably they're not dying. But no, my question was completely different. My question was completely different. You're saying it's so simple. Think things through. Well, I mean, it's almost impossible, especially when you're beginning to do stuff. How do you actually think things through?
Oh, me? No, I
No. It was your idea, so I'm asking you about your experience.
Oh, thank you.
Okay, because somehow it triggered me. I think microservices are not the solution to everything, but a great solution for a certain type of problems in certain context. Thinking things through, of course, we cannot have an answer for every question. We don't know what happened in the future. But mostly what I see in my professional career is, oh God, we already solved it so many times. Why haven't you thought about it? You know, there's this principle of 5W. Yes, why? Yes, you ask someone why would like to do it, why would like to do that, and so on. But mostly we don't think about things we already have done several years, and we repeat mostly our mistakes. And if we would think about this, we would always become a bit better and faster. We cannot answer everything. That's my opinion. Maybe you have a different
Yeah.
opinion.
Well, I mean, there's a lot of examples, right? So, you know, let's just say in the context of should we have a monolith, should we start migrating to a microservice architecture, right? So the short, or we have microservices, and we need to implement a new subdomain. Should it be part of an existing service, or should we introduce a new service? And then in those contexts, the dark energy, dark matter forces that I discussed, which like a dark energy force would be team autonomy, that encourages you to put subdomains in different services so the autonomy of the team is improved. And then like a dark matter force would be, let's say, prefer ACID over eventual consistency, right? Because sagas are complicated and ACID transactions are simple. That would be a reason to put those subdomains together. Yeah. Well, in the same way that sagas are not always complex and ACID transactions are not always simple, but let's just assume that things are straightforward or not. So it's like when you're in the context of making a design decision about should I have a new service or not, the criteria by which you judge the candidate solutions, and you should always brainstorm candidate solutions, end up being the dark energy, dark matter forces, right? So that's an example of a big decision that you should think through. And then also, if you look at the world of design patterns, right, which are quite numerous, I mean, one key element of a pattern is a set of forces, which are the things that you need to take into consideration when solving the particular problem. And then the patterns consequences section tells you the trade-offs and the benefits and the drawbacks, right? Which are what forces are resolved and which forces are not resolved. So once again, it's like if you take a patterns approach, you're trying to solve a problem, you look at some candidate patterns, they give you the framework for thinking things through. So in general, you want to make a decision of some consequence, brainstorm what kind of success or what evaluation criteria you should use, brainstorm some candidate ways of doing things, and then evaluate them, right?
Is there a framework for making correct decisions?
Not really. I mean, a lot of it depends on your judgment, right? And specifically, a lot of the time there are conflicting issues, right? Like, once again, eventual consistency is more complicated than ACID transactions, right?
It is actually very simple compared to ACID transactions. Just for the record.
But you know, so you've got, if we put things in separate services, the teams are more autonomous. But if you but then you end up needing to use a complicated saga. You know, which is the best approach, right? And you end up having to pick the least worst one.
Okay, I feel the urge of stopping this already starting panel discussion. There is something that's, let me get you the microphone, and I think then we can free the stage for the next speaker.
Thank you for the talk. I have a question, and because the monolithical applications we already building are not as monolithical as they were a decade ago or something. So when does the microservices start? So where is the switch between a monolithical application to the microservices?
I guess the interesting thing is there's not a hard number, right? Like in a sense, I mean, sort of roughly speaking, it's like the number of teams that you have working on an application continues to grow, and then at some point, their ability, the monolithic architecture becomes an obstacle to fast flow, right? And it's there's not a magic number for that, but it's sort of like you as an architect need to be, our goal is to practice fast flow, and the cognitive load of the teams should be low. Their team should be working independently. So you're sort of quantifying all of that, and then if you see it start to dip, then you try and fix it by improving your development practices or whatever. But then at some point you could conclude it is because of our monolithic architecture. And if we start extracting out services, then it will accelerate software delivery again. So it's sort of like So eventually if your application and organization keeps growing, you could possibly have a problem that can only be solved by introducing microservices. So so I'm talking about this tomorrow at the Software Architecture Gathering Conference, and it was just like, you start with a monolith whenever you can, and just keep growing it, and then look for signals to go, oh, we need to switch.
Okay, thank you. Thanks a lot. So I think that's the time for the applause.
Thank you. Thank you. Oops.
Okay, I already introduced myself as a fangirl, so I have a few books of him in my bookshelf. I think we also have a few books to give away today, right? Yes, yes. Yeah, we can do a signing thing. Yep. You want this microphone or help with the? Yeah. Yes, I think so. He wants the headset. Yeah, if you want, you can grab a drink. We need like 1 minute to set up the headset, but then we should be there very soon. Don't leave us.
It's on. Test. Okay.
Yes, you can take the drinks to the seats again. We're setting it up because we also want to do a bit of a panel afterwards. If you've seen, we already have the speaker here who are like wanting to go in this intense discussions. So we really want to have some time for that as well. So let's come back so the next speaker can start.
Hello.
It is fine. Okay, so let's start with a big applause for Vaughn Vernon.
All right, so do you like this title? So you're going to crash. That's true. Yeah. Actually has nothing to do with automobiles or any kind of, well, it has to do with computing machinery. So maybe you've heard the expression, let it crash. Has anyone heard the expression, let it crash? So that's kind of what this is going after. Does anyone here remember the Simpsons episode where Homer ate fugu? Do you know what fugu is? It's a sushi. It's the blowfish, and the blowfish has a toxin in it. And if you eat some of the toxin, it's like a real reward to your taste or something. You know, you get a little tingly feeling. But if you eat too much of it, well, Homer got this message. You know, so you're going to die because he ate fugu. Of course, he didn't die, but this is where I got my title. So you're going to crash. You remember, what has it been, a whole week or so? Remember this meme? Maybe you've seen it. The entire internet is resting on top of Cloudflare. And by the way, AWS East, US East 1 is held up by a little peg, but everything else is balanced on a pencil tip on top of the finger, right? And when Cloudflare went away, a lot of things went away for quite a while. So, do we have fragile code? Is your code fragile? I think it is, almost certainly. Do you know what caused this one problem? This one line of code right here, one expression. It was an uncaught. Now everybody loves REST, right? I mean, Rust. Isn't Rust like the new language, everybody's choice? You can't go wrong if you use Rust. You're not going to ever have unsafe memory, but you still have exceptions under some conditions. So yeah, someone unwrapped. Do you know what unwrap is? If you know Rust, maybe you know what unwrap. You probably know what unwrap is. But if you're familiar with Java, think of option or optional, and you can look inside the option, right? So this is basically the same kind of thing in Rust, where you have a wrapper around an object, and the wrapper tells you basically you have something or you don't have something inside, and so you supposedly can't get a null pointer exception because you have this wrapper around it, and basically you use kind of a monadic expression, and that can be a map, right? You can map on that optional or option or try, something like that, and you can, or I should say not try, but maybe, right? On a maybe, and if something is there, you're going to do this. If something isn't there, you're not going to do it. But someone here unwrapped. And what they unwrapped was not good, right? It was a value that they weren't expecting to have to deal with, and yet they did. And so it took a lot of the internet down with it. And following this, maybe you got into one of these arguments yourself. Did you see any of these? Don't unwrap. No, you can unwrap, but only in a library. No, never unwrap in a library, only a framework. Well, isn't a framework in a library about the same? Well, and then it goes down another whole rabbit trail. Never unwrap in production, but you can unwrap and test. Wait a minute. Aren't you testing the same code that you're releasing? And so how would you unwrap and test, but not in production? Yeah. So this is kind of where when I finally, I didn't actually know what unwrap was because I don't know Rust well. I haven't really programmed professionally in Rust. So I was like, what is unwrap? Is it sort of like Java unsafe or something? And then I looked into it and I was like, that's what unwrap is? It's an option, get essentially, right? Optional get. And so we're going to look at what's inside. And I said, oh, so that's what they're talking about. Well, I could tell you stories about programming in Scala that probably just already told you, oh, wait a minute, are we talking about the Scala that's a little bit better than Java, or are we talking about the Scala that people have to use because they can't program in Haskell, right? Well, the people I was working with at the time were the ones who were bitter because they couldn't work in Haskell, so they were just programming in Scala. And if else, even though if else is an expression in Scala, as in it can return a value, if else should be removed from the Scala language. That was the opinion of the FP people that I was working with. And anyway, I won't even take you any further, but it got into this sort of ridiculous, change these 5 lines of code because you shouldn't be using an if-else expression that returns a value, which was completely safe because either you got what you needed or you didn't, and you got something else that you could work with. And I got tired of sort of, trying to gently defend my position on this. And the insistence was to change it to map, which of course, if you map over this object, you're only going to map over the thing that exists. But if you need to take into consideration what isn't there also and do something in that case, you're not going to do it. And so it results in 5 bugs. And they didn't believe it until they saw the 5 bugs. Anyway, so these arguments, they're such pedantic kinds of things that just, I think they lead nowhere useful. But have you read the book, and whatever you think of this guy, I really don't care, but he makes some very good points about Anti-Fragile. Have you read the book Anti-Fragile? Nassim Taleb. He also has a book called Black Swan. And essentially what he's talking about is that failure happens. In fact, we go to such lengths to try to prevent failure, right? That people will say, well, what they should have done here is assert at the top that this wouldn't happen. And the assertion would cause what? If it's in production, it's going to cause an exception. And the exception is what caused the problem in the first place. So what I would argue is people aren't going to try to cause exceptions in error situations. They're going to try to prevent exceptions from happening. And so the only way you can assert in production, assert at the beginning here is if you anticipated, if you knew that that was going to happen, right? Then you would assert that that shouldn't be the case. And so you don't enter this code in the first place, but you fail fast, except for the fail fast would have also caused an exception. So do you kind of see this as a trap at this point? You're kind of saying, well, wait a minute, what do I exactly do about this? Well, Nassim Taleb says, fail. Failure is good. You absolutely need failure for a system to work. You have to teach people to fail and take risks. Okay, well, they did fail, didn't they? I mean, Cloudflare failed in a very big way. By the way, I love Cloudflare, okay? This is not finding fault with Cloudflare. This is just software, right? This could have happened to anybody. This is not like me standing up here saying, oh yeah, well, I would have never made it. I've made plenty of mistakes like this, and you have too, right? So it could have happened to any of us. Okay, so if you do need failure and you are willing to allow failure to happen, how do you deal with it? You know, these $2 bills, they could be, you know, euros, how you say it in German, you know, but what is the characteristic of these two $1 bills? They're not identical at all, right? One is old, worn, it's been in circulation for quite a while. One looks brand new. They have different serial numbers, but you see this word replaceable. This means that both of those $1 bills have the same value, right? If I have whatever, a $1 bill and you have a $1 bill and we exchange them, you may not like the condition so much of, you know, if you have a newer bill and I have an older bill, you know, if we're exchanging these two and you say, well, I didn't really want this older, you know, but does it really matter, right? We're even now. We just exchange the $1 bill and we're even. Okay, so they're replaceable. Well, what if we could do that with software? This is a running object. I like to draw these, sometimes I like to draw objects as circles, and I'll explain why in a moment. But this object is accepting messages, or it could just be simple method invocations, right? Method invocation, method invocation, method invocation. If you know anything about event storming is a way to represent commands, things that you're telling an object to do, and the orange represents the things capturing the facts about things that have happened, okay? And those are called events. And that's why it's called event storming. So this is not event storming, but what I'm doing is using the colors of sort of sticky notes or the representation of the colors that we use in event storming to represent things in a software model. This circle is an object. In particular, this is an actor, okay? If you've heard of the actor model, and if you've used Scala or Java or Microsoft Orleans or well, how could I forget to say Erlang and Elixir and so forth? So you're at least somewhat familiar with the actor model. An actor is an object, but the object receives messages asynchronously. So even if you are like a JavaScript, TypeScript developer, you're familiar with async await, and when you start async await, you're async await all the way down, right? You need to use async await. Here, you're going to use async await all the way at the top of your call stack, right? And the reason that you do that is because if eventually you get to a point where a call causes a block on I/O, or essentially what would cause a block on I/O, instead of blocking on I/O, the that sort of stack frame is frozen or released, the call is made, asynchronously by some other means to cause the I/O, like make a REST request or save something to a disk or a database. And then the event loop or the message loop in JavaScript is still running, and it takes control again. It gets control of the thread, and it dispatches to something else that's waiting to run. Okay, so you can even have actors in JavaScript, TypeScript. In Java, you would have really true multi-threading if you were supporting multi-threading. And I could talk, for hours about that, but let's move on to just give you an idea of this is running software. What if this object crashes? So we have the situation where we didn't know that an unwrap, and we looked at the object, the thing inside, and it was a null or something we weren't expecting it to be, and we hit that and boom, right? The exception is thrown, and when the exception is thrown, we didn't expect it. Even if we are catching exceptions, maybe it's a runtime exception or an unchecked exception, and the unchecked exception bubbles all the way to the top. And you're thinking, well, that's what it does anyway, all the time, right? Like nobody catches exceptions. We just let them bubble up to the top, and we log them from where the controller or the REST endpoint or something. We vomit that out into a log file, and we go back to the user and say, try again later, right? I mean, that is just the way we do things. But is there an alternative? What if we could actually treat this like a dollar bill and a dollar bill? And we could just simply replace this when the crash occurs. I mean, okay, well, then isn't that just as good as letting it bubble up to the top, letting that log message go out and, the stack trace and everything? And isn't that just the same thing? Well, it could be, but that's not where this is leading. Okay, so let's say that we could replace it, but we're still dealing with, okay, what happens to the exception? Is it just going to bubble up to the top again? And so somebody has to deal with the exception, even if we replace the object. And replacing the object has value to it, because if something is corrupted inside, we don't want to keep working with that data that's not in the state that we want it to be, right? So we're going to just replace that object. And then, so we just have our world famous error, please try again later, and we dump the stack trace onto a browser page, right? Your resource just returns in a response, and there's your, what is this? This is an Oracle JDBC device driver exception that happened on the server side, and the user, of course, is going to know what to do about that. You have to admit, this has happened a lot, right? A lot. So, you're all thinking, well, I hope he doesn't know that's happened to us on our team. Yeah, everybody sees this kind of thing. Why does this happen, though? Ask yourself, fundamentally, what is the problem here? Anybody have an idea? Why are we, is it laziness? I don't think it's even laziness. I mean, sometimes it is, but what are we doing when we let that thing go up to the browser, or we just plop it into the log file and keep going, right? What are we actually doing? In the US, when we talk about the NFL, right, we say, well, you're punting. You're saying, let's get rid of the ball because it's fourth down and we can't get a first down, almost impossible to do that. So let's just punt it away. right, to the other team. So you get the ball as far down the field as you can. And that's what we're doing. We're punting. We're saying, we don't know what to do about this. That is actually what we're saying, right? We have just concluded, I'm a controller. What am I going to do about a database connection failure? Right? I mean, really, what are you going to do about that? Okay, what are we going to do about that? Well, I'll tell you what, instead of exceptions, why don't we use try, right? So essentially we wrap the failure in essentially, again, what is an option, but the option in here is a success or fail, right? And so what you have inside there is essentially an exception or the result of a exception. And does that help? I mean, it's the same thing. You're not getting the long jump essentially out to a point on the stack that where you have this catch somewhere that doesn't know what to do about it. Instead, you're just going to return it, and as soon as the thing above it sees, uh-oh, it failed, what's that going to do, right? The problem is we don't know what to do about any of these things. Why? Because this here is a worker. This here is sort of whether it's a UI controller or an application service, which is kind of a use case controller, right? So the UI, the user makes a request. We receive the request in a controller or an endpoint, same difference, same thing. And then we say, okay, I'm going to convert this REST request to something that the application inside can understand. And so we use an adapter to do that, and then we hand that off to the application service, and the application service says, well, I know how to load a domain object from a repository, and I know how to hand that request off to that in an application meaningful way. But boy, if it fails, I have no idea what to do about that, right? And how many different failures could there be? I mean, I'm talking about database connection here, but it could be, many dozens of things, maybe hundreds of things, and things that we didn't even anticipate. Okay? So the connection is an abstraction, but it's a leaky abstraction. What connection? What is it? Why did it go wrong? Is it that the network itself failed? Did the database fail? Is it just one node on the database? Should we retry and we'll get redirected to another node? Essentially a partition, right, on the database, and so we have automatic recovery. We don't know. We just don't know what to do about it. So this worker and the application service and the controller they should not have the responsibility to deal with this. Why? Because it's just simply not their responsibility. Every single one of these abstractions here, controllers, message handlers, application services, workers, whether that's a domain service or a domain object, an aggregate of domain-driven design, a value object, repositories, message handlers. Oh, I already had that. Well, maybe you have multiple message handlers. But the point is, they're supposed to do one thing really well. A controller is really bad at handling exceptions because it's supposed to be a really good controller, right? That is its single responsibility. It's a separation of concerns, and the concern that we have in a single responsibility is to be the best possible controller we can be, not exception handler. So we're actually, in a way, not really doing anything wrong. We're just admitting that we're only trying to be a single responsibility handler, right, of some kind. And so, in a sense, okay, nothing wrong with that. But we still have the problem. What are we going to do? This is the answer right here. You know, we were talking on the walk over here with Sandra and Timo. Where are you, Timo? There you are. And Timo said he visited a very well-known e-commerce company warehouse where they watch people who work in the warehouse who are responsible for picking items off shelves and putting them in boxes, and you know, and they watch them like hawks, because you know, if you want to increase someone's self-worth and productivity, you treat them like they're doing something wrong all the time, right? Isn't that like the best thing to do with people? Is yeah, so maybe you know who we're talking about. And well, yeah, that's what this person is. What are they? They're a supervisor. Okay, a supervisor. They're here to make me do things that I should be doing and avoid things I shouldn't be doing. Well, that sounds pretty good, doesn't it? When we're talking about things that one kind of concept, one abstraction should not be doing. And so, why don't we create something like a supervisor? If you know anything about the actor model, if you know anything about Erlang Elixir, essentially the beam, right? The virtual machine that runs Erlang. And if you've used the actor model in Java, in C#, well, not with Orleans. I think they don't really have, I think let it crash is more like the virtual object just goes away and you send it another message and it reloads, which is not really supervision. It's just continuous failover, right? But what is a supervisor designed to do? A supervisor it has the responsibility of dealing with problems, whether it's an exception, an error, which is essentially an exception, right? An error in JavaScript, TypeScript, anything like that. That is what a supervisor is meant to do. So, how does this work? An exception is thrown. This object is now trash, right? The exception is put in an envelope and it is sent as a message to the supervisor, which itself is an object. And so it has this wrapper around it, and the supervisor says, well, what happened here? Oh, I know how to deal with that. Why? Because I'm designed to deal with that very error that has occurred. That is what I do. And so we essentially are designing what has been called a domain of failure, right? So we have the business domain itself, the domain model, which is reflecting the business concepts. And then when we have failure, we should have a separate model for failure. And that is what supervisors are. They are a model that handles failure. And if this particular supervisor does not know what to do about this exception, well, there can be any number of supervisors that what is called escalates that error or exception to, and it just keeps passing it up until something deals with it. And then you have a default supervisor in the supervision chain, if you will. And the default supervisor is basically a bulkhead that does what the Titanic was, supposed to do. And it just says, okay, it stops here. We're not going to crash. We're just going to tell the object to restart, because that's all we know how to do. And we will log it. But it can be even more intelligent than that. If you have this execution context, which basically tells the whole world, on this thread right now, This is the context of what we're trying to do. And if we know what the context is of what we are trying to do, anybody who has that context can take the error and react to it. And if nothing else, we can tell the user interface something intelligent, right? Instead of just blah. With an exception stack trace, we say, oops, it looks like there was a problem storing your changes, right? There is no database failure, try again later. There is no connection error, right? Nothing like that. Oops, I mean, you know, if you're gonna be friendly to people, wouldn't they like to hear oops instead of right? Oops, it looks like there was a problem storing changes, but don't worry, we have all the data safe and ready to store as soon as the problem is resolved. How do we do that? Well, I mean, we could use session storage or local storage on the browser, or write it to disk, bring it back. You know, there are all kinds of ways to not lose their data. And when we recover the database connection, and let's just say it will eventually recover, well, we're just actually in the background. We can write it. We can write it to the database in the background because we know this happened. But you know why we can do that? Because we have a domain of failure. We have a design around failure. And as Nassim Taleb says, you're not going to know all your failures all at once, so you need to let failure happen, but recover from it in the best way that you possibly can. Let it crash, but not burn, right? Let it crash, but not burn. Make a note of it, and then deal with it as immediately as possible, as soon as possible, which can be immediate or near immediate, okay? So do one thing well. Supervisors are really good at handling exceptions. Supervisors should be the best possible supervisor of that particular situation. And in that way, a worker doesn't have to be a supervisor. The supervisor is essentially spying on, right, or looking after the best interests of the worker, whatever that worker is, whatever the object is that it's protecting. And so you're saying, okay, but how do we actually make this happen? If you have something as simple as a proxy that wraps every danger point in your system, in your microservice or monolith or whatever. So if this is a domain object, a business object, or something that knows how to do something for the business, it will have a proxy around it that has the exact interface as the inner object does, and it receives the method invocation or the message, right? The message that it's receiving, and it immediately dispatches down to the worker, and it catches the exceptions. That's its only job. Dispatch, catch the exception. If the exception happens, hand it off to the supervisor. You don't even need asynchronous messaging for this. You can do this without asynchronous messaging, okay? So even if you're thinking, man, do I have to really deal with like async everywhere and my mind is going to explode because, you know, well, you know, here's the thing, right? You may think of it as 1 million things happening at once, or 2 million things, or 1 billion things happening at once, but however many threads you have on the machine, that's how many things can happen at once. And the OS is going to use some of those, right? And certain facilities are going to have some of those. So even if you have a pool of actual Java threads or .NET tasks or whatever it happens to be, and you are truly capable of parallelism, you're still only going to be doing a finite number of things on that box, that machine, even virtual machine right now. So don't panic too much, right? Because that might only be 10 or 12 things, or it might be 24, it might be 60 something, or 100 and whatever, but it is a finite number of things that are happening right now. And if you can understand two things happening at once, it's all the same now. They just can have a thread or not. So, but you don't even have to go there for that. You can do this without asynchronous messaging. Okay. And if you're thinking contextual, this is, I don't want to go into this too far, but this scales, right? The supervision scales. This is just showing two different bounded contexts from a DDD mindset. You have a downstream context and an upstream context, and they're communicating. This is sending a post command message over here, and when this happens, an event is being emitted from this upstream context, and it's flowing back down through a message bus, and we're consuming that in a listener, and something breaks, right? Either something breaks here or something breaks here, and the proxy simply can have like a plug-in circuit breaker, exponential retry with back off, and capped. You can cap it, so you can say, oh, we're only going to go up as much as 30 seconds of back off, and then we're just going to remain at 30 seconds until something fixes itself or gets fixed. So this scales all the way, right? And whether you are actually completely restarting this object, restoring it from its previous state that it had before, whatever the case, you can completely restart it, restore it, ignore, and keep going. There are various options with supervision to do this very flexibly. Whoops, I'm sorry, I keep hitting the, okay. So if you haven't read the book Anti-Fragile, it has nothing to do with technology, really. It's a financial services book. Talib is, a quant, I guess you would say, but a really extremely brilliant one or something. And yeah, so if something is not fragile, it doesn't automatically mean that it's anti-fragile. Anti-fragile is Talib's terminology for saying we're going to benefit from failure. Not being fragile does not equal necessarily this. What if you never learned from failure, but you prevented it from destroying your system? That's not anti-fragile. That is just not fragile. Do you see the difference? Right? So you're actually, if you're anti-fragile, you are benefiting from failure. Okay. So design a domain of failure. And I've just recently released this. So if you're into JavaScript, TypeScript, it's actually Domo Actors and Domo Tactical are TypeScript first. I apologize if you hate TypeScript and you love JavaScript, but I think you can still use it okay. And I also have a Python release of Domo Actors. And the thing is, right, it's using async await, but it's not multi-processing. It's not parallelism. It is concurrency, and it's using JavaScript TypeScript concurrency, which means there's just one thread. Okay, and you can find these on GitHub.com, my personal place. Domo Tactical is dependent on Domo Actors, and it's providing the DDD tactical modeling tools for TypeScript and JavaScript. I have not implemented the Python yet because I just want to see if anybody's interested in using this first. But myself personally, I'm doing a lot of TypeScript development these days, so this is, at least for me. If no one uses it, I feel bad for you. That's all I can say. Okay. I mean that in a humble way, but I do really think you should look into it, okay? If you would like to learn about domain-driven design, we just sold another 3 registrations today on December 8th through 11th, I believe it is. Anyway, if you just go to iddworkshop.com, it will take you to the right place. It actually goes to our company website, which is kalele.io, but yeah, this is an easy way to remember it. So if you'd like to attend, and we are going to go over AI, domain-driven design with LLMs, right? And I'm using Claude Code a lot these days, and I'm giving a talk tomorrow. I'm actually keynoting at the Architecture Summit, ISAQB Summit. By the way, I got invited by Stefan Tilkov and Mirko ages ago. I was actually right after my first book was published, and so I've known the two of them, and of course, horrible loss with Stefan. But so I really enjoy working with Mirko, and so I've just gladly come over here to work with ISAQB again. So if you have a chance to join us there, I'm keynoting in the evening tomorrow. It's like 18:30, I think it is, something like that. So anyway, yeah, this is, so you're going to crash? Oh, it's a little puppy, sweet little puppy. Puppies don't hurt you, they're so cute. You can just enjoy the crash. Okay. By the way, I do have a lot to say about microservices and monoliths, and I will say some things a little differently than Chris. Chris is like very, very good at what he does, but I've got some other. So if you're going to stick around for, are we having a panel? Are we going to do that? Are we out of time or? I don't know. He's, Chris looks pretty tough. I'm not going to mess with him, but no, he's good. I'm all respect for Chris, but I do have a few different opinions. So, okay. Any questions I can help you with?
So you are introducing these supervisors. So will it have any impact on the JVM performance, for example, garbage collection?
Well, okay, garbage collection. Maybe. So if we go back here, notice this is a platform that I created. The Zoom platform is actually Java and .NET. I actually worked on the Java side. A colleague and good friend of mine, Tomasz Jaskula in Paris, worked on the .NET side. And I'm just going to be frank with you. We just didn't have the uptake that we were hoping for. I released 1.0 of this 60 days before the lockdown of COVID, and it just, that was just like the worst timing in the world for this. But the Java stuff is out there, and it is totally, you have a real thread for every real thread that you have on the machine, and this uses it. So you do actually have parallelism and concurrency with this. So yeah, when you talk about Java and garbage collection, but garbage collection with actors works the same as garbage collection anywhere. When it goes out of scope, right? When no one has a reference to it anymore, it's garbage. Is that what you?
I mean, you are creating this proxy object on top of these workers.
Oh yeah, well, so this, whoever has a reference to this and holds that, when they release this no longer has a reference, and the only reference to this is this, right? So when this goes away, this gets freed also, collected. Yes, sir.
Do you think that some of this functionality should be in the kernel? So it's like more than with the reincarnation?
Well, the beam is essentially a kernel, right? That's what it is. And so I don't argue against that, but also I mean, I had this discussion recently somewhere on, and a guy just, he loves Erlang and the Beam, and I don't blame him, but he's trying to convince me and others that every enterprise on Earth is using Erlang, and that it's just simply not true. So I mean, it's not like I'm happy that that's not the case, but it's just simply not true. And so, but yeah, it would be great if it was in the kernel. The problem is, like, I was having a discussion today with a colleague, and he's like, the thing is, and he's a Scala actor model guy too, so he gets the whole supervision idea, and he said, but the upstream, or it's like we're swimming upstream against the current, because the DevOps people are the ones who claim essentially we are providing supervision for everybody, right? When it crashes, we just restart a Kubernetes pod, but right.
Was exactly the same concept that has been implemented 30 years ago in the kernel with the full exactly in the same way supervisor, but the reincarnation, that operation was called.
Say again, maybe I didn't understand. You're saying that Kubernetes does provide?
No.
Yeah,
In the
it
kernel
doesn't.
time when was still the fighting between Linux, Minix, and the others.
Yeah.
Then we have a reincarnation. Then we call when the process was dying, we call reincarnation. Then because it was restarting reincarnation in the same process, and then was a supervisor making X2 and managing the
Okay, but the kernel, I guess, is benefiting from it, but nobody else does. I mean, if the crash goes so deep that you're going to take the kernel out and the kernel prevents it, that's good, but that didn't help the application or the service or the utility or what.
The
Right?
idea was also to bring up to the process, not only the kernel process.
So you did this work yourself, or?
Yeah, well, I was part of one of the open source project of more than 30 years ago.
And which was it?
Well, the first implementing that one was Minix.
Minix.
Yes.
Okay. I thought you said Linux. Okay, interesting.
No, that was the fight at that
Yeah,
time.
okay, yeah.
But after that, some idea was also in Solaris, but
Yeah.
never end up in the operating system.
Okay. Well, what have you got to lose besides a bunch of serious crashes, right? So give it a try. I mean, at least experiment with, that's one thing that, I was going to say that I view a little bit, and maybe, that Chris would agree with this. I probably would, but someone asked, is there a framework for, how did it go? For being right or understanding? And I think the framework is called experimentation. So hypothesis, hypothesis tracking, experimentation, and that's the quickest way to understand whether you do understand or you still don't, right? So hypothesis is not, it's simply, what am I trying to say? I have had like 5 hours of sleep in the last 3 days, and the Coke Zero I just still hit a brick wall just then. I'm trying to think of what, yeah. So basically, hypothesis is it's a hypothetical, right? You're saying if we should try this because it seems like this could help, this could work, and if it doesn't, then you learn. You didn't fail. You failed, but you didn't fail overall. You simply learned another way that didn't work, and so you go through a process of elimination. And if you think that that is like wrong-headed to look at it that way, if you go clear back to Thomas Edison said, we didn't fail 10,000 times. We found, 10,000 things that didn't work. And they eventually found something that did. So I'm pretty sure you won't have 10,000 failures at experiments. So, but give that a thought anyway. Yeah. I probably took longer than 20 minutes, didn't I?
So, where's the microphone? Thank you for. Hi. So I hope you liked the meetup so far. So who had a good time? Yeah, nice. So in the beginning, we had a short time where we could do networking, and as you saw, like we had some technical things to solve, which we ultimately succeeded, luckily. But now we fell a bit short in our timekeeping, right, for that regard, and also in terms of networking, we cannot like come to fullest capacity. So therefore, we want to ask you what is your consideration containing the next steps in this event, right? So we have some people here who would have been happy to answer questions, right? But we want to hear from you if you should like approach a panel at all, or if you want to have like casual Q&A with the speakers we had already, and maybe the other people loosely included, or how would you feel right now, right? Who wants to have a panel? Okay.
Who wants to have some Q&A to previous speakers?
There is a few for Q&A.
Who
Okay.
wants to just like add their chat to go home?
There's a few. Like, and many people didn't raise hands at all. So
So yeah, okay.
give us a hard choice.
Have our speakers for some extra questions, or maybe some other people presenting to answer. Yes. So yeah. Okay. So please, questions, or like if you want to go, please. Sorry for that. We also have here Chris to answer your questions if you want. So
Folks, until you left, we will post in like
Yeah.
a week
Yeah, that's
a link to
Hey,
questionnaire
okay.
about Kotlin. Please go to this questionnaire and answer it. It's very important to Russ and to JetBrains. Thank you so much.
What we will do is like we have a bar next door. So everybody who is like into that, we would be happy like to continue there. And yeah, next time we try to like stick to our promises. Thank you so much for coming.
We kind of managed it.
Okay. Alles okay bei dir? Ja.